Okay, we're going to work on some of the problems from the worksheet labeled Calculus 1500 Related Rates. We're going to start with problem number 1. The problem says an airplane is flying towards a radar station at a constant height of 6 kilometers above the ground. So let's start by drawing the airplane at a constant height of 6 kilometers above the ground. Okay, there's my airplane. There's the ground. And this height is always 6 kilometers. If the distance s between the airplane and the radar station, here's my radar station, and here's the distance, and this is labeled s. It says this distance is decreasing at a rate of 4 kilometers per hour when s equals 10 kilometers. What is the horizontal speed of the plane? Okay, so they said that it's decreasing, so ds dt is negative 400 kilometers per hour. And they want us to find the horizontal speed of the plane. So if we call this distance down here x, okay, so this distance on the ground is x. We're trying to find dx dt when s equals 10 kilometers. It's important to watch the units like the kilometers because sometimes they'll make one of the units meters and another unit kilometers. So you have to make sure that you watch that. Okay, so first we need to make sure that we have an equation that will relate the three sides of our right triangle, because that's what we have here is a right triangle. Usually the equation for that is going to be the Pythagorean theorem, but if they're ever talking about angle measures, then you're going to have to use a trig equation like sine, cosine, or tangent. But in this case, we're talking about the three sides, so I'm going to call this side over here, this height, I'm going to call it h. The Pythagorean theorem says leg squared plus leg squared equals hypotenuse squared. So the equation we're going to use is going to be h squared plus x squared equals s squared. Now we do have to take the derivative of this equation because we have rates. So the derivative of this will be 2h times dh dt plus 2x times dx dt equals 2s times ds dt. The next thing we're going to do is start plugging in the values that we know. Now we know that the height does not change. The reason that we know that is because they told us that the height was always 6 kilometers. So that means that this value right here, dh dt, is going to be 0. So we're going to have 2h times 0 plus, at this point in time, they have told us that s is 10, but they have not told us what x is. So I'm just going to leave 2x times dx over dt equals 2s, which is 10, times ds over dt. And they told us earlier that ds over dt is negative 400. The 2h times 0 goes away. How am I going to find the value for x? Well, at this point in time, we know that h is 6 because h is always 6. We know that s is 10 at this point in time. And we also know that h squared plus x squared equals s squared, because that's the Pythagorean theorem. If you plug in h and s, you get 36 plus x squared equals 100. And you'll find out that x is equal to 8 kilometers at this point in time. So we can plug that into this other equation. We have 2 times 8 dx over dt equals 20 times negative 400 is negative 8 and 3 zeros. And when you divide negative 8,000 by 16, you get dx over dt equals negative 500. And our units, x is measured in kilometers and t is measured in hours. So that's negative 500 kilometers per hour. Now we can look back at the picture and see if our answer makes sense. They told us that ds over dt is negative 400 kilometers per hour. So that means that the plane is getting closer and closer to this radar tower at a rate of 400 kilometers per hour. But it's maintaining this constant height of 6 kilometers. So does it make sense that that this ground distance should be changing at a rate of 500 kilometers per hour? I think that number makes sense to me. Okay, let's try another problem.